So here we start. Hi everybody, welcome to this talk. My name is Vincenzo. I work for EssilorLuxottica, and in this presentation I will tell you how we used NodeJS, Puppeteer and Google Chrome to create our virtual try-on solution. This is a story of life, from the battlefield. Okay. How many here use NodeJS? Yeah, someone. How many here have ever automated browser tasks? Good. And anyone here has ever used the WebGL to render something server-side? Okay. So it's most everybody fresh here. Okay. We'll delve into these technologies used to simulate the experience of trying on glasses digitally and, well, drive a browser server-side. And at the end of the slide, we also have an hands-on session demonstrating debugging techniques or providing insights for software engineers looking for how to run multiple browsers server-side. If you want to be in touch with me, here we have my Twitter contacts and a GitHub link. So I think a few people here recognize EssilorLuxottica as a company that invests on technology and digital innovation, right? Yeah. EssilorLuxottica, sorry, is a leading player in eyewear industry and has a great interest in open source software and innovation. We are commonly recognized as a manufacturing company, and we actually invest heavily in product innovation technology. We love open source because they forest collaborative development, allowing the company to leverage a global pool of talents and ideas, enhancing their technological capabilities and innovation. We recently started to join to wonderful events like Voxer Days, and we love introducing ourselves with the unusual approach of a video, explaining who we are and what we do. In the video, we'll also find some moments with amazing technological products like Nuance Audio that will be launched later this year, a new concept of glasses, of medical glasses device to help people with hearing disabilities, or Ray-Ban Meta glasses in collaboration with Meta. Enjoy the video, it's just 3 minutes, and then we'll deep dive into our virtual try-on solution.
We are EssilorLuxottica. We are a global leader in world-class vision care products, including iconic eyewear, advanced lens technology, and cutting-edge digital solutions. As a vertically integrated, open network company, we are driving the transformation of the eyewear and eye care industry, partnering with every player to deliver the next generation of care to consumers and patients. We stand boldly at the intersection of multiple categories, from medtech and digital to luxury and now hearing solutions, making us a natural catalyst for change and a beacon of possibilities that shines for the entire industry. We are a diverse and inclusive community of over 200,000 talented employees in 150 countries, driven by our common mission to help people to see more and be more. EssilorLuxottica is home to more than 150 brands, including the most influential and recognized vision care and eyewear brands in the world. Through more than 300,000 third-party locations, ranging from independent opticians to optical retail chains, and our 18,000 stores, we offer consumers products they love, high-touch eye care they trust, and a best-in-class shopping experience that creates new standards to elevate the entire industry. Rooted in our origins, innovative thinking is our way of life. We do not see boundaries. The future, with all its untapped opportunities, is a source of inspiration that drives us to create, experiment, refine, and implement new ideas and technologies. From digital optometry and telemedicine to AI and big data, we are moving the industry into a new era of interconnectivity and intelligence. Bringing a full universe of innovation into our iconic eyewear and lenses, we are building entirely new categories from the ground up, making vision care a gateway into a new world of possibilities. Expertise and knowledge are key to supporting this transformation, and with Leonardo, our learning ecosystem, we are offering next-level education for the industry at large. Doing right for our customers, consumers, and communities while caring for the planet is at the heart of the group's strategy. Through our Eyes on the Planet program, we are taking steps to minimize our environmental footprint while maximizing our social impact. Promoting good vision as a basic human right, we are working through the One Sight EssilorLuxottica Foundation to help eliminate uncorrected poor vision by 2050. Together, we'll continue to protect and frame the beauty of the most precious gift, our eyes. See more, be more. EssilorLuxottica.
I hope you enjoyed the video. Here are just very briefly some numbers, but I don't stop the presentation on this slide. If you want to go deep, we can talk about later, okay? Okay, so let's go straight to the core of our talk. EssilorLuxottica is one of the richest eyewear offering: sunglasses, prescription glasses, masks, and accessories. We have a customer coming from all over the world, really, and a wide variety of touch points between e-commerce sites, wholesale, and retail sold. So how to choose my glasses? Well, how to help our users to interact with such wide catalog. That's the point. Having all this variety of actors is a huge problem. After years of work, we designed our glasses virtual try-on. Let's have a look at the highest level of our virtual try-on. We start from a user photo, just a user photo, from which a 3D mesh of the head is extracted. Raise your hand if you know what a 3D mesh is. Oh, well. For those of you who don't know what a 3D mesh is a model. It's just a file with a collection of vertices, edge, and faces that together form a three-dimensional object. That's the three-dimensional object is the head of the user. It's used for visualization and prototyping. Well, we used to put the glasses in the right position. Our computer vision system, puts together the 3D mesh of the user with the user photo and the 3D glasses. Together with the WebGL-based viewer, we managed the web camera flow and the glass 3D models. So, and voila, our users are able to virtually wear our glasses. But where is the VTO used? What are the use cases? The VTO is used by e-commerce, wholesale, and retail integration almost everywhere. Enhancing online retail experience, providing virtual try-on as a service, revolutionizing the eyewear shopping experience, attracting tech-savvy customers. But honestly, we do much more. The VTO is useful in marketing and customer engagement. Let us create an innovative marketing campaign and improve the customer satisfaction and retention. But let's go there. Where does the magic happen? Let's look inside this thing. Let's dive into our technology stack. Our technology stack, it's almost simple. Okay, our technology stack is composed by 4 parts. NodeJS is a cross-platform. Most of you know what is it. Puppeteer is the library that we use internally. The Puppeteer is a NodeJS library which provides a high-level API control over Chromium. Google Chrome, well, you know what is it. Okay, I haven't said anything. And the VTO core is our JavaScript library. It's the library that does the magic using WebGL and our machine learning models in order to understand where the 3D mesh is. So here's the journey. After the user upload their photos, Node.js is responsible for handling the request for the image generation, for running the Puppeteer code execution and the image response. But what does Puppeteer? I said Puppeteer is a Node.js library and is able to start the browser headless. In other words, with Puppeteer's API, you launch/connect a browser, create some pages, and manipulate them. That's how we automate the task, like overlaying glasses on a user image. The virtual try-on is a component running embedded the page. The Node.js itself is serving the virtual try-on pages, where the VTO and WebGL render the overlay glasses. The key feature of this architecture, this product, this software, is the real-time image processing, the enabling user-friendly interface, the digital prototyping, very important. So, yes, it's friendly, but we do not enable the user to wear digitally every kind of glasses, even if they are not available directly in store. But the very important part is that we enable the digital prototyping. To be clear, digital prototyping gives us the ability to virtually explore a complete product before it's built. In other words, our most valuable customer will be able to see the new glasses long before they are even built, when they are only in the mind of our designers. So, what are the development challenges? Well, handling the image data. Efficiency was not about the size of the image that have to be created on the fly. Most of the work is done by the browser collecting all the data and rendering the image. Having a GPU in the server where all this is running will help a lot to reduce the render time. Converting a front-end application to a server-side application, we learned that JavaScript is ubiquitous due to its role in the scripting for web development. We enabled both server-side and client-side development in this project. The performance optimization. We had to maintain a smooth user experience and balance the resource usage and responsiveness, but the memoization was the pattern we used heavily. It comes from functional language and is used to remember the result of a function. The main idea behind memoization is to execute the function only once. Follow-up calls should not run the logic, but return the cached result. This would help a lot, even if you have to use the same image a lot of times for the user, the same 3D mesh, the same glasses again and again and again. This pattern helps us a lot in reducing the amount of work we have to do. And regarding the performance monitoring, one of the trickiest parts we faced was about this application is that we have code running inside Node.js and at the same time inside the browser asynchronously. So, I'll give you an hint about how this thing works in the hands-on session. Running multiple browsers, to manage, we decided to manage multiple browser instances server-side because we decided to containerize our application. In each container, there is the entire solution, a microservice that run the stack and the browser, Node.js and the browser. Given that the application is completely stateless, we can add containers in the architecture and scale horizontally. That would help a lot. So, in conclusion, leveraging on Node.js and Puppeteer, we created a seamless digital try-on solution. What were the takeaways? We understood how strong JavaScript and TypeScript are in the development, and those helped us moving or reusing, how to say, the people who work in front end also in the back end in the server side options. But let's go in the hands-on solution. I have prepared a full functional sample of what we did. Very simple, obviously, where we have an application that create a browser, launch browser, and let's see here, yeah. And is able to take a render from the browser what the browser is doing. So here we have a JavaScript code with a simple handler. Here we created the browser and just write a console log. Here we create a new page in the browser, a new tab, to be clear. And we ask the browser to go to a specific URL. But, well, it's just something that gives us an hint of what's going on into the browser. We here attached the Node.js application to an handler, the console handler. So everything was written into the browser can be cached here, and we can see the page log prefix with the following text together. Here we have another very important API. Here, this API is able to run this JavaScript code inside the browser. And once we have this thing, at the end we can have a screenshot of the entire browser page, and here we have a buffer, which is basically a PNG image that we can send back to the user that made the request. Here we close the page, close the browser, and everything is finished. So let's see this thing run. Okay. The assembly is started. Here we are. I put a breakpoint here just to give you an hint of how easy is debug the code and see what's going on inside the Node.js. This sample is fully functional and is available at the URL I shared before. Here we have the object that has been created. Well, let's remove the breakpoint and see what happens again. Okay. Here we have the screenshot. We have a small screenshot of the page. Something went wrong, honestly. let's try again. And what? Okay, this is the full screenshot. But this is a Chrome bug, not my fault. And well, here we have something that is useful. Now we can see what's going on in the browser. To be clear, the browser we are using right now is not the browser that has done this, has rendered this page. It's an headless browser, which is running under the hood. It's completely, yeah, headless. Okay. Let's try again with something different. Okay. Here we are. Now we ask it to the browser to render the /GPU inside internals configuration, and we can see that it's available on my machine. This would be very useful if we have to render something server side. But have a look, just have a look at the logs. As you can see here, this console log window resides that I have asked to execute here has been catched by the trigger I put here, no? And now we can see what is happening inside the console of the browser. So all the message running in the console browser will appear here, even if they are written directly in the browser. They are not coming from my injection, to be clear. So let's go ahead. So if everything is clear, and if anybody has any question about, I can go ahead. I have a more complex sample to share with you. Okay. Okay, here we are. In this sample, I would like to share how to, it's more real world sample. In real life, we do not launch for every request a browser. And for every request, we don't create a new page. We are used to have a pool of browser and a pool of pages. So actually, what are doing right now? We are creating a browser, storing in a global variable, and creating a page, even that is stored. And now we are reusing the page. We are interacting with some code inside the page, asking the code to do something useful, and receiving the result. Taking the output. So the page we are asking is this one. I'll show you the page. Oh, sorry. I had to start the sample. Yes, this is the sample. Very simple. I just draw a cube. I can change the rotation. I can do it by myself here, but I will try to do the same thing using our code. Let's go back to the code. Oh, well, just have a look if we... Okay, now go back to the code. So, what's happening in our sample? So first of all, when the Node.js application, the Express application starts, we create the browser, write something in the log, create a new page, catch the console, go to the page. This page is served internally by Node.js. So we basically, the browser reuse Node.js as web server in order to load the resources that we need to run the code inside the browser, the headless browser. And I call a new function which basically render passing a parameter, just and the degree of rotation to the function which is inside the browser. So now we can, as you can see, at the first start, create a browser, create a page, load the page, call the function inside the browser with a parameter, and wait for the render complete event. So now the browser inside headless has an image to be taken somehow. But now we can call the request handler, asking for a parameter, always the same, the rotation parameter. And call the function. This will ask again the browser, the page, always the same page. We are using the same page to render the image for a new rotation. And once this was done, now we can select the element in the page and do something with it. Well, it's easy. Well, we are, again, just doing a screenshot. We can do much more. But anyway, this is just a simple sample. So I would like to just to give you an hint of what's going on inside. And send back the response. Oh, sorry. Yes, here we are. Now we can call again and again the page, asking for a different rotation, and this will be calculated on the fly, and well, we receive back the image. As you can see, inside the page, we catch the console log and write the number that we received from the user, from the request. Okay, I think it's everything for now. Any question? Ancora 15 minuti. Okay.
So you did this in your React project, so the virtual try-on?
Yeah.
For both uploading the configuration for the client,
Yeah.
and also for security reasons, I guess. Like you doing this, doesn't allow, so you don't allow the user to inspect the code of what you're doing.
Not really, no, that's not the real problem. We do because we need to produce an amount of image in production, We really need to have the image of the glasses worn by the user, not something that is running in the user browser. So consider if you want to show the users all the glasses that he could wear, it's not feasible running in the browser multiple instances of this software and that throw multiple WebGL context altogether. It's very heavy to run in the. Yeah, we run is in a specific server that is prepared to produce all those images for a user that would like. Let's go back to the presentation. Consider this case. Here, this is a user, and he would like to see how he feels with different glasses. Maybe those glasses are not. You can understand how different they are, no? Because we are suggesting glasses that could fit well for the user, but they are all different, no? And the user can see what's the glasses, how stay with the glasses in his face, you know, her face. That's the point. You have you used it? That's the point. That's the point. We also use this because we have, as said, for the digital prototyping. You know, we have to produce image of how of new glasses for the most valuable customers. So that's a real problem. In the beginning, our company spent a lot of time producing and built glasses that no one has bought. They were not interested, for the people that at the end was not interested into. So that was a real problem. So now we can save a lot, just understand early if a glass is is really appealing for the people, it's fashionable, has a market, the people can be interested into. No? That's a real thing. And having just a JavaScript application that is running in the browser side is not enough. It's not a good solution. You are right about the possibility to preserve the code, but that's not the point. It's a different point. It's most about the performance, there are scenarios in where we cannot run so much virtual try-on altogether in the customer machine. Anyone else?
Yes, regarding server-side generation of images.
Yeah.
There were other technical solutions for rendering the image, other using Chrome and WebGL, because some editors claim to use a client-side technology to render server-side images.
When we started long ago, there weren't, honestly. There was something, but wasn't in the open source world, honestly. It wasn't maintained anymore. And it was built on top X server, JavaScript, and with C++, it was unmaintainable. So we were also working together. We were already working on a browser solution. So once we started to work in the browser, we find out that it was most easily because the browser give you a lot of facility for the WebGL programming. There is a lot of, there is a big community. There are resources. Not in server-side world is not, well, recently there were a few new projects that are changing the scenario, but when we started a few years ago wasn't the same situation. And in the end, we find out that we could reuse the knowledge, the developers, the resources that they were able to develop browser side, and now they are also able to develop server side, given the NodeJS browser Puppeteer integration. Hope I answered the question. Anybody else? Okay, here we go. Bye. Okay, if you want to stay in touch with us, here we have our LinkedIn link. Here is my Twitter account. And if you are interested in the sample, here is the well, the QR code. Okay, anyway, if you want to come here, I give you any explanation. Bye.